data sets that have two rules in them, right? Two sets of patterns that we're looking at. And today we're going to take that and we're going to think about, okay, with a data set that has two sets of rules, how can we then visually represent that as a line graph? And so we're going to use this as our first example. Let's say I'm working on a craft project, and in that craft project, I'm going to be using lots of copper wire for an art piece, okay? Each $2 bag of copper wire contains 6 meters of wire. Our job is to find the ordered pairs and graph the data, and then find the rule that relates price to the meters of wire, all right? So let's start by thinking through the information that we've got so far. We know that every time we've got a $2 bag of wire, there's 6 meters in it, right? So we know our cost in dollars, and then our wire in meters. So here's my table, right? My cost, I notice, is $2. For $2, I get 6 meters. So I'll continue on. For $4, then I would get 12 meters. 2, 4, if I'm counting by sixes, right? Because each time this is going up by 2, right? Because each bag costs $2. 2, 4, 6. Then down here, I need to multiply it by, I need to be adding, sorry, not multiplying, I need to be adding 6, right? Because from 6, each bag has 6 meters, and 6 to 12 is 6. And I'll add another 6, and that would get me to 18. And then up here, I'll add another 2. That'll get me to 8. Down here, I'll add another 6. That will get me to 24. You might also be noticing, Ms. Sharma, you could be looking vertically and thinking 2 times 3 is 6. 4 times 3 is 12. 6 times 3 is 18. And you are absolutely correct if that's what you're thinking. And we'll leave it at that. All right. So now what we're going to do is we're going to figure out how we can visually represent this data. Well, we have 2 different scales here, right? Here I'm moving by 2s, here I'm moving by 6s. That's okay, as long as you stay consistent with your scale. So let me set up my x-axis and my y-axis. And my x-axis, I'll have my cost in dollars. And then on my y-axis, I'll have my copper wire in meters. All right, now let me quickly sit down here and think about my ordered pairs, right? I know my x-axis will be 2 and my y-axis will be 6. Remember, x always comes first, so my ordered pair is 2, 6. I'll continue that for my other 3 pairs. So I have 4, 12, 6, 18, and 8, 24. Now I need to go back to my axes and label my scales, right? So I know I'm going to start at 0, and then I'm counting by 2s for my cost, right? So I have 0, and then 2, 4, 6, 8, 10, 12, and I can stop because I know I'm only going up to 8, right? My copper wire, I'm counting by 6s, right? So I could move by 6, I could move by 1, I could move by any factor of 6. So I really want to be able to see that the relationship between these numbers. So I might go ahead and, let's say I decide to move by 3s, right? So then I would have 3, 6, 9, 12, 15, 18, 21, 24, 27. All right. And now notice I'm moving by different scales, right? Here I'm moving by 2s. Each unit over here is worth 2. Over here I'm moving by 3s. That's okay. My scales can be different as long as the interval within the x-axis remains the same throughout, and as long as the interval between each number on my y-axis remains the same throughout. So it's okay to have different scales as long as our numbers are staying consistent in between each number. The interval is staying consistent between each number. So now I'm going to use these ordered pairs that I created from my table to go ahead and start plotting. So I have 2, 6, so I'll go 2 on my x and 6 on my y. cross it out so I know I'm done. 412, 412, 618, and 824. All right, and now I'm going to grab my ruler, and I'm noticing this should form a straight line because my pattern is consistent throughout. So if you notice that you've got a point over here, and your line would go make the zigzag shape, that would not be correct because our pattern stays consistent throughout all of our data, right? We're always multiplying by 3 vertically or adding 2 and adding 6. So our pattern should form a straight line. So I can take my ruler, line it up, and go ahead and put a line through my data, right? I'm not going to extend it past my data because I don't have any information there. And actually, you know what? Even though technically it's not on our data set, I could include 0, 0 in there too, because if I have 0 bags, I've spent $0, right? So if I have $0 spent, how much meters do I have? 0, right? So I could create that line all the way to the origin, and it would look like that. But I'm not going to extend past my data because I don't have that information plotted yet, right? So here's a simple way that we can take our data that has 2 patterns, right? We have 2 different patterns here, adding 2 or adding 6, and we can create line plots that have 2 axes with different scales, right? And those scales have different intervals. However, I can still visually represent my data in the same way that I've been doing so far throughout this chapter. And then I could think about my rules, and I could say, well, we're adding 6 to the meters, we're adding 2 to the cost, or we could say that we're multiplying by 3, and that describes the relationship between the cost and the amount of wire that we're receiving. So you guys are going to have a chance to try a couple different problems, and I cannot wait to see your work. Thanks, guys.